So some more review of algebra. For example, the absolute value of 2x plus 3 is greater than 1/2 x minus 1. So let's recall about absolute values. Absolute values give way to two statements that you learned in pre-calc. So I'm not going to go through the why, just recalling it. So when we see the absolute value equals something, we drop the bars and we say the inside stuff equals the positive or the what? Negative. So when it's equal to, we drop the absolute value bars, we take the inside stuff, and we rewrite the other side as positive and negative. When it's the absolute value of x is greater than something, greater is or. It means x is greater than a or x is less than negative a. The key here is that greater means or. Look here, everyone. When I have rewritten this, it's without the absolute value bars. You take the inside stuff, whatever it may be, no matter how big or long it is, you set it greater to the other side, put or, take the inside stuff, and it's less than the negative of the other side. When it is less than, it means x is greater than a and x is less than negative a. So less than is and. Notice this is what you've got to get to. These are the interpretations, and the interpretations of those are made without the absolute value bars. So less, I always tell students, go LA. Greater is or, less than is and. So in this one, it's greater. What word is greater? Or. So I'm going to rewrite it with 2x plus 3 is greater than 1/2 x minus 1. Greater is or 2x plus 3, switch the symbol. When you switch it, you make the other side negative. So just run the negative sign through it. Now these are inequalities, but they're linear inequalities, meaning the highest exponent on x there is x to the first. So how do I solve linear? Well, I'll get the x's to one side. But before I do that, I'm going to multiply through, just to help you out, by the least common denominator of 2. So what's 2 times this, everyone? Come on. 4 what? 4x plus what? 6 is greater than x minus what? Subtract x, get 3x. Subtract 6 and get what? Negative 8. Divide, and x would be greater than negative 8/3. Or, multiply again through by 2. Eliminate the denominator. So I'll get 4x plus 6 is less than negative x plus 2. Add the x to the other side and get 5x. Subtract the 6 and get what? And get negative 4, correct? And x is less than what here, guys? Okay, so we got to talk about this as a solution here. What does this look like? Or means, or cannot be ignored. Listen to me very carefully. You have to appreciate ands and ors. Are you listening? Ands and ors are operators. Or means to join the answers together. You unite the answers together. And means you intersect your answers, meaning what they have in common. So we've got to OR these. I won't take that as an answer if we can do better, guys. We have to do something better. So let's graph this. Let's see what it looks like. So I'm just going to erase this over here so we can get an idea of what's going on. Here's 0. Sorry about that. Here's negative 1, and here's negative 2. So negative 4/5 is getting pretty close to negative 1. So that's an open circle there at negative 4/5. And less than that there, I didn't make any errors there, is like that. Agreed? Yes? Now, where does negative 8/3 fall? Where does that fall? Well, that's past negative 2, isn't it? It's negative 2 2/3. So that's going to be an open circle. And numbers greater than that will be in this direction. Well, I'm joining everything. Remember, I'm joining everything. So if I unite this, what's my answer really? If I unite these two answers, numbers greater than negative 8/3 or numbers less than negative 4/5, if I join those two number lines, really what's my answer? Why just negative 8? Isn't negative 10 less than negative 4/5? Isn't negative 10? Isn't positive 10 greater than negative 8/3? What's my answer then? Negative infinity to what? It's all reals. It's all real numbers. It's all real numbers. Let's take a look at this so you understand this. X is greater than 1 or x is less than negative 2. So just suppose you did some work and you got that. Here's negative 2. That's less than negative 2. This is x greater than 1. If you join those answers, what is your final answer? Yeah, it's as good as you can get. Negative infinity to negative 2 in union with, that means in joined with, x 1 to infinity. Yeah, you can't do any better than that. Now what if I do this? X is greater than 0 or x is greater than 1. What's my answer now? Very good. 0 to infinity. Good job. Because numbers greater than 0 are also greater than what? We're joining them, so essentially it's 0 to what then? And that's all because of the OR. Now hold on. What if I say and? The numbers have to be greater than 0 and greater than 1. The answer is not that number. It's what? Very good. It's from 1 to infinity. It's where they overlap. It's where they intersect. And in the other one, when it was out to infinity this way, and we had the 2 here, there is no overlap. There is no number greater than 1 and less than 2 at the same time. Well, that's negative 2 it was, I think I had. Sorry about that. So there's no overlap, so there's no solution with the and then on that. So or means to unite, and means to intersect. And if there's no intersection, then there's no solution. Okay, try this one. The absolute value of 1 minus 2/3 x is less than x minus 2. So we see absolute values, and that's going to mean how many things for us? Two statements. What's the first statement? 1 minus 2/3 x is less than what? What's going to go next? What's the key word? And, good. 1 minus 2/3 x is greater than, and just run the negative sign through, So negative x plus 2. I would multiply through by 3, the least common denominator. What's 3 times 1, everyone? Minus 2x is less than 3x minus 6. I'm going to get the x's to one side. I'm going to subtract that and make it negative 5x. Subtract the 3, make negative 9. Divide, and x is greater than 9 over 5. And don't forget, you have to reverse the symbol. Here I'm going to multiply through by 3 and get 3 minus 2x is greater than negative 3x plus 6. Add the 3x over and get x, right, is greater than 3, I believe. Right, everyone? How does that look? And this is and. And I won't take this as a final answer if that answer can be improved. You just can't go like that. I want you to and the answers. So to help you with that, draw a number line. You'll never go wrong with the number line. So this is from 3 to infinity. 5 over 9, that's 1 4/5. Do you agree? Right, everyone? So that's back here. Where is the common overlap? If I'm doing and, I need the common overlap. Where is it? 3 to what? Good. That's the final answer. We're okay with that then? An appreciation for ands or ors, I hope. All right, next little bit stuff is function notation. In calculus, we work a lot with function notation. So let's suppose we have f of x equals 2x squared minus 3x plus 1, and g at x equals 3 minus 2x. Just a couple real quick refresher on function notation, and then we'll do some practice. So we're going to do this notation. Watch up here, everyone. F minus 2 times g at x. Notation here. Many students want to subtract the two functions. Well, first they'll multiply g by 2, subtract them, and multiply it by x. This x here does not mean to multiply. It means f of x minus 2 times g at x. That's what it means. If I were to throw a plus sign in there, it would mean f at x plus 2 times g at x. If I throw a minus sign, a times sign in there, it means to do f at x times 2 times g at x. And divide would work the same way. It does not mean to take this and multiply it by x. I don't write this notation because I can just do it from looking at this. So the original is f of x, 2x squared minus 3x plus 1. And now I'm going to do minus 2 times all that. So I'm going to do minus 2 times 3 minus 2x. Clean it up. Minus 6, that becomes plus 4x. Combine your like terms and get 2x squared plus x minus 5 with that. Next, f times g at 2. What would that mean notationally? F times g at 2. What would that mean? Yes, it means f at 2 times what? So putting 2 in, I get 2 squared is 4 times 2 is 8 minus 6. That's 2 plus 1 is what? 3. 2 into here would be 3 minus 4 or negative 1. And what would my answer be then? Negative 3, right? Okay. What would this mean to do? You recall this one? F at g at 1. What is that? Isn't that function composition? One function embedded in another. You see that all the time. Look up here so you understand that. This right here, when you were graphing this is function composition. It's really the square root function embedded with another function, x minus 1. Functions embedded in functions. So this means you start on the inside, g at 1. And what's 3 minus 2 then, everyone? Now it becomes f at 1. So this equals 2 minus 3 plus 1. And that comes out to be what? Negative 1 plus 1 is what? 0? Remember function composition? Okay, and this is really huge here, is this. F of x plus h minus f at x. Do you understand what that means notationally? Can somebody explain to me what this means? When you see f at x plus h, what does that mean to you? I'm sure, go ahead. F at x plus h, what does that mean to you? I mean, what would you do? What does this mean to you? What does that mean to do? For x. Right. So you
plug in x plus h.
You substitute wherever there's an x, which you may want to box, you're going to replace the entire function. This means, listen here so you understand, everyone. This is notation. This means the function f evaluated at x plus h. This means the function itself, f at x. You're going to run a minus sign through there. So out goes the x, in goes x plus h. But I'm not done yet. Do you understand what I've written? This is the function at x plus h. Yes? Minus the function means to run a negative through that. So it'd be minus 2x squared plus 3x minus 1. You're not done because you have to square this binomial. How do you square a binomial by sight? Square the first, multiply, double, square the last. So x squared is x squared. Multiply is xh, but double it is what? Plus h squared. Now what I do is I cross it out like that and I put it there and then I go through the whole thing again. Because I'm not going to rewrite the whole thing all over. So the final answer would be 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1. So combine your like terms, and in combining like terms, the 2x squared will drop out, the 3x's will also drop out, and the 1's will also drop out. And what remains is 4xh plus 2h squared minus 3h. Okay? All right. So let's go to the board and do some practice.